Okay, this is a short video lesson on the ambiguous case law of sine where we have two sides and an angle. And for this particular exercise, I have three different triangles. The first triangle has angle alpha, or if you want angle A, to be 80 degrees, and side little a to be 11 centimeters, and side little b to be 12 centimeters, and our task is to solve the triangle. So if we set up our sides, A is 11 and B is 12. We don't know C, that's to be found. We have alpha, or angle A if you want, to be 80 degrees, and we don't know angle B or beta, and we don't know angle gamma or C. Those are to be found. So knowing that the law of sines deals with a pair, we would certainly start with that ratio. And since we're looking for beta, I'll set up my law of sines as the sine of 80 degrees, that's alpha, divided by A, and that's going to be equal to the sine of beta, which we're looking for, divided by 12. So again, we're pairing up these guys and these guys. Those are the two ratios. We set up the proportion using law of sines. Okay, from there we can easily solve for the sine of beta. It looks like the sine of beta will be 12 times the sine of 80 degrees over 11. Now, before I grab my calculator, I want to just look at this particular value. And as I go to my calculator, let's see, in degree mode, I have the sine, 12 times the sine of 80 degrees divided by 11. My calculator says 12 times sine of 80 divided by 11 says this is equal to a number greater than 1. Let's see if I can punch this in one more time. Okay, so I have 12 times the sine of 80 divided by 11. My calculator says this is approximately 1.074. Now, if we were to continue working this problem, we would see that we have the sine of beta is equal to a number larger than 1.4, and that should tell you right off the bat that this is impossible, because we know that sines are limited between plus and minus 1. If we actually went and charged into this and said, give me the sine inverse or the arc sine of 1.074, you would see immediately this is not possible. The error message that I get from working this says error domain, and then the options are quit and go to. If we go to the error, which I would always recommend you try, the problem is right there at the sine inverse of this quantity. Okay, so that's we cannot find an arc that has a sine greater than 1. This triangle is an impossible triangle, and so with this information, you should be able to say pretty quickly that this is a no triangle possible. Or if you want, you could say this is an impossible triangle. And that would be the way you'd finish that problem. Okay, now for my second example, I'm still going to have side-side angle, and I'm still going to have alpha given. This time it's going to be 50 degrees. Side A is still going to be given, and this one's going to be 8 centimeters. And once again, I'll give side B. This time it will be 10 centimeters, and our task is to find the remaining parts. So we have B, we have side C, and we have gamma. Okay, so our task, and just like before, we notice that this pair is set up. So that's the ratio I'm going to start with. I'm going to have the sine of 50 degrees over 8 is equal to the sine of beta over 10. And my calculator takes that very nicely. 10 sine 50 degrees over 8 is the sine of beta. So beta will be the sine inverse of this quantity, 10 sine 50 degrees over 8. And when I go to my calculator, I'm just punching all that in, sine inverse of 10 sine 50 degrees divided by 8, I get beta 73.247 degrees, rounding to the nearest thousandth of a degree. And let me go ahead and put that here as 73.247 degrees. Now, this is going to be an ambiguous case, and in fact, we have two possible values for beta. We have the 73.274 degrees, but let me call that beta 1. Beta 2 down here will be 180 degrees minus the 73.247. And so if I jump on my calculator and just figure out what that is, I get 106. Beta 2 can be 106.753 degrees. And let me put that back into my chart here. 106.753 degrees. Now, before we go any further, a little explanation I think is in order. When we looked at the sine inverse of this quantity right here, we found that beta was 73 degrees. And if I illustrate 73 degrees, that's approximately right about there. So this is my 73 degree angle. But in point of fact, remember there was another angle that our arc sine would not reach that has the same y coordinate. And this red angle is what I'm calling beta 2. So the one going all the way to there is the 107 degree angle. And this second option will always be 180 degrees minus the first one. So you need to check that each time. Okay, so for this particular triangle, we have two possible values for beta. Now that leads, interestingly enough, to two possible values for gamma, gamma 1, gamma 2. And those are easily found. Just remember the angles of a triangle have to sum to 180. So if I take 180 less beta 1, 180 less the 73.247, and less the 50, that will give me my gamma 1, so 56.753 degrees, and that will pair up with beta 1. Maybe I can do all of these in blue, beta 1, and then all the second possibilities in red, so we can keep track of them. So gamma 2, and again, what we'll do here, we'll take beta 2 and alpha, add those, and subtract that from 180. So 180 degrees less 106.753 and less 50 leaves me with 23.247 degrees. Okay, so we've got two possibilities for beta, two possibilities for gamma, and of course, depending on beta and gamma, there would be two possibilities for C. So we're going to have C1 in blue, we'll figure out what that is, and then C2 in red, and we'll figure out what that is. Both of these would be found using the law of sines, and I'll go back to my given fact right here at the very beginning, the sine of 50 over 8. So let me clear off a little bit of room here, right over here. So we have the sine of 50 degrees over 8, and then using gamma 1, I'm going to have the sine of 56.753 0.753 is going to be over C1. Okay, so doing a little bit of, in hindsight, it may be better if we flip this over right at the beginning. Since I'm looking for a side here, it doesn't make sense to put the C1 in the denominator. Let's rewrite this so we have C1 in the numerator. So we're going to have, let's see, C1 over the sine of its angle, 56.753 degrees, is going to be 8 over the sine of its angle, which is 50 degrees. Okay, so C1 is 8 times the sine of 56.753 degrees divided by the sine of 50 degrees. And again, I'll clean this up just a little bit to give me some more room to work. And getting on my calculator, I should have the sine. Let's see, here we go. 8 times the sine of 56.753 divided by the sine of 50 degrees. And I get for C1, 8.734. And because this is a length, I'll use the same units I have for A and B, centimeters. Okay, for C2, I'll grab the red pen here. C2 over its angle, 23.247 degrees, will be the same as 8 over the sine of 50. Again, I'm going to go always back to this original given, if given a choice, and not really mess with the rounded values beta. But I get C2 will be 8 times the sine of 23.247 degrees divided by the sine of 50 degrees. And again, just cleaning a little bit of room here. My calculator says C2 is going to be equal to, I could probably just edit what I have there, change the 56.753 to 23.247, and I get 4.122 centimeters. Okay, so there's the solution to my triangle. I've solved the triangle. This is the ambiguous case, and we really have to take into account both possibilities. Now, for my third triangle, once again, I'm going to have side angle. And once again, I'm going to give you alpha is 65 degrees. I'll give you A is equal to 7 centimeters, and B is going to be equal to 5 centimeters, and our task is to solve the triangle. Okay, so once again, notice that we're paired up here, so we're going to go after that ratio. I'll be looking for beta. I have the sine of 65 degrees over 7 is the sine of beta over 5. 5 times the sine of 65 degrees over 7 is the sine of beta. And beta is going to be the sine inverse, or the arc sine, of this quantity. 5 sine 65 degrees over 7. Before I jump on my calculator, let me just get a quick approximation for that. 5 times the sine of 65 divided by 7. That number's about 0.64. So there should be no trouble here. This is not going to be an impossible triangle. We have the sine inverse of 0.647367. Okay, that's what beta is going to be. And so now hitting the sine inverse button, we get beta is equal to 40.343 degrees. And I'll go back up to my chart here. Beta is 40.343 degrees. Now, you might want to wonder, is there a beta 2? Well, suppose beta 1 was 40.343 degrees. Remember how we found beta 2? We took 180 degrees minus beta 1. That's what we did in the other example. So our beta 2 here would be 180 degrees minus 40.343 degrees. Well, we have a problem here. Our beta 2, if there were one, I'll better put some question marks there, is going to be equal to, again, go to my calculator and just 139 degrees and some change, 0.657 degrees. Okay, so this is not possible. Not possible. It's not that a triangle can't have a 140-degree angle. Of course, there's two triangles that have that. But why is it not possible in this case? Well, because we know we have a 65-degree angle already given. So with a 65-degree angle, we could not have another angle of 140 degrees because obviously the sum of the angles of any triangle is 180. So there is no second case here. This is a side-side angle problem where we get a unique value for beta, not two values. Okay, so that makes things much, much easier. Let's go find gamma. To find gamma, just add alpha, beta together, subtract it from 180. So 180 less, let's see, 180 less the 65 degrees and less the 40.343 gives me a gamma value of 74.657. And because we only have a single value for gamma, we have but a single value for C. So let's chase that down. We have C over the sine, again, law of sines, 74.657 degrees is 7 over the sine of 65 degrees. So C is 7 times the sine of 74.657 degrees over the sine of 65 degrees. C, going to my calculator again, 7 times the sine of 74.657 degrees divided by the sine of 65 degrees equals 7.448. And that would go right here, 7.488 centimeters. Okay, so I've solved the triangle, and this is a unique triangle. Even though it is the side-side angle case, it's not an impossible triangle, and it's not ambiguous. Okay, done. Now, what I'm going to recommend you do is to try to rework these three problems from scratch and see if you can get through the mechanics. Triangle 1, again, we had alpha is 50 degrees, we had A is 8 centimeters, and we had B was equal to 10 centimeters. Triangle 2, we had alpha was 80 degrees. We had, take it back, this was actually triangle 2 here. This was triangle 1. Not that it much matters. One is impossible, one is ambiguous, and one is unique. So maybe you can just write down these three setups. This one was 11 and 12. And this last guy, we had alpha was 65 degrees. And A was 7 centimeters. And B was 5 centimeters. So I think it would be good practice to take each one of those, work them through, find which one is impossible, find which one is unique, and for the one that's ambiguous, again, check not only beta 1 but also beta 2. Make sure that you chase down gamma 1 and C1 and gamma 2 and C2. Happy trig!